doing math with our HB, and we're looking at lesson 33, which is addition of fractions. Pull this up a little bit. Addition of fractions, lesson 33. All the preliminary lessons we've had before are leading up to the add, subtract, multiply, and divide, and then problem solving that we're going to do involving fractions. The overhead is a little bright, but I turn it on. All the examples are on that, and take a look at adding fractions. If you add fractions, you have to have a common denominator. Common, another word for it is same. This is one of the longer lessons because there's so many different parts. So example 1, same denominator, 14, 14. Numerator is 3 plus 2. So you keep the common denominator, you add the numerators, and then you reduce the answer if you can. Now in the case of 5/14ths, we have 14, 14, common denominator is 14, we keep it. 3 plus 2 is 5. Can't go any lower than that because the only number that'll go into 5 and 14 evenly is 1, and you'll end up with 5/14ths again, so there isn't any point. Looking at example 2, what happens if the denominator excuse me, is not the same? So it's different. If your denominator is different, you cannot do addition. You have to find a common denominator. So you have to change to equivalent fractions. We talked about equivalent fractions in lesson 30, I believe. And if you look at that, equivalent fractions are fraction forms of 1, and that's what we need to be looking at. So we have a half plus 3/4. And so we don't have the same denominator, so we need to find one. You have to look at all the denominators in your question and find a common one where all the denominators will divide evenly into that example. So in this case, 2 will divide evenly into 4, 4 will divide evenly into 4. So we can just use 4. In this case, 3/4 won't change. So it will be 3/4. And half, if we change this to a 4, 2 times 2 gave me 4, so 1 times 2, because whatever you do to the bottom of a fraction, you have to do the same to the top. So 1 times 2 will be 2. Now we can actually add. Our common denominator is 4, so it stays. Not very good 4. 2 plus 3 is 5. And you reduce if possible. You can reduce it. In this case, we have an improper fraction. 4 is the denominator and it's smaller than the numerator. So we need to take the 4, divide it into the 5. How many groups? You get one whole group of 4 and you're going to have 1/4 left over. You can't reduce that any smaller. So that's your answer. When the equal sign's here, beside the question, you just keep going along. If the equal sign is not there, it may need to be started over here. We'll take a look at some of those examples. Mixed numbers, number 3. Move this up. Keeps getting caught on this piece on overhead. So I'll make sure I'm on the screen here. Yes. Mixed numbers. If you have mixed numbers, you have a whole number and a fraction. A whole number and a fraction in this case. So we cannot add this. We can add the whole numbers, no problem. We can't add the fractions because they have uncommon denominators. So they're different. So we need to look at changing that. So the 2, our whole number is going to stay. One of the easiest ways to find a common denominator is to multiply the two denominators together. 3 times 2 will give us 6, and that way we know that 2 will divide evenly into 6, 3 will divide evenly into 6. And in this case, that will be our lowest possibility. Sometimes multiplying them together gives you a huge number, and there's usually a smaller possibility. So we multiplied 2 times 3 to get 6, so therefore 1 times 3 gives me 3. 3 times 2 gave me 6, so 1 times 2 gives me 2. Now to add it, 2 plus 1 is 3. My common denominator is going to stay 6. 3 plus 2 is 5. I can't reduce that any lower because 1 is the only number that will go evenly into 1 and 6. So those are the 3 basic examples. We're going to take a look at more questions. This is one of the more difficult things when we start getting into adding, subtracting, multiplying, dividing, and I'm way off the screen here. What am I doing? Okay. So we're looking at adding fractions. In this case, we have a common denominator. Question 1, 8 and 8. So that's no problem. We just put an 8 and we add the numerators. 3 plus 2 is 5. Simple. Number 2, we again have a common denominator. So that makes it simple. The equal sign's here, so you follow along. We use the common denominator. We add 9 plus 7. We get 16. But this can be reduced because 16 is larger than the numerator. In this case, is much larger than the denominator. So therefore, we need to do something about that. How many 10s can I get out of 16? I can get 1 whole group, and 6/10 will be left over. I can still, make sure I'm still on the screen here. Move over. I can still reduce that more. 1 will stay. That's my whole number. 6/10, 2 will divide evenly into 6, 2 will divide evenly into 10. So if I divide that by 2, and I divide this by 2, I'm going to end up with 3/5. So question 3, uncommon denominator. We don't have the same number. So we have a 9 and a 5. The lowest possible denominator in this case is going to be 45. So I've multiplied 9 times 5 and it's 45. There isn't a smaller number that 9 and 5 will go into evenly. So we're stuck with 45 plus 45. So we multiplied 9 times 5 to get 45. So 7 times 5 gives me 35. 5 times 9 gave me 45, so therefore 2 times 9 is going to give me 18. If I add these, 8 and 5 is 3, carry a 1, 3, 4, 5, I end up with 53 over top of 45. We have an improper fraction, 53 over 45, therefore we're going to have to divide. How many 45s can I get out of 53, sorry, 1. Therefore, I'm going to end up with 8 45ths left over. 2 will not divide evenly into that because 2 won't divide evenly into 45. 3 won't work with 8. 4 won't work with 45. 6, 7, 8, that's our answer. We can't do anything more with that. Now I've given 4 the same question twice because in this case I have a 4 and 10, a 4 and a 10. So I've used the exact same question. I'm going to show you that it doesn't matter if you use a larger denominator or a smaller denominator that's workable, okay, you'll still end up with the same answer. The second way is a lot more work. So if we have 4 and 10, we're going to put our equal signs underneath because there's no equal sign here, so that tells me it should be underneath and to the left. So 4 times 10 would be 40, which is fine, but we also know that 20 will work. So 20 plus 20. So I multiplied 4 times 5 to get 20, so 3 times 5 is 15. I multiplied 10 times 2 to get 20, so 3 times 2 gives me 6. So I'm going to end up with 21 over top of 20. How many 20s can I get out of 21? I can get 1, whole 1, and 1/20 will be left. Make sure I'm still on the screen here. Am I not? Yes. Doing the same question using not the smaller denominator, I'm going to use the larger denominator, and you can see you'll end up with the same answer, just an extra step. So we have, instead of 20, I'm going to use 40. 4 times 10 gives you 40. So I multiplied 4 times 10, so I've got to multiply 3 times 10. I get 30. 10 times 4 gave me 40, so 3 times 4 gives me 12. So I end up with 30 plus 12, my common denominator is 40. 30 plus 12 is 42. So therefore I'll end up, how many 40s can I get out of 42? I can get 1, and 2 40ths will be left. Well, 2 will divide evenly into 2, and 2 will divide evenly into 40. So therefore you're going to end up with 1 and 1/20. So the answer does end up the same, just a little more work and one extra step here. So if you're having difficulty, just multiply the denominators together. So we end up with the last two. Raise that up. 5 1/10 plus 1 2/5. The whole numbers are fine. We need a common denominator. In this case, 10 will work. 10 here, so we just use the 1/10. 5 times 2 gave me 10, so 2 times 2 gives me 4. And I end up with 6, and 4 and 1 is 5/10, and it can be reduced down to 6 1/2, because 5 will go into 5 once, 5 will go into 10 twice. This is what I mean about there being a lot of steps. It can get quite confusing. 1 1/2 plus 1/6. So I have a mixed number and a proper fraction. So the mixed number, the whole number is fine. We need to find a common denominator. 6 will work because 6 will go into 6 and 2 will go into 6. So we multiply 2 times 3 to give us 6, so 1 times 3 gives me 3. Oh dear, that's not a very good 3. So we end up with a whole number and 4 over 6. When I reduce it again, because 2 will go into 4 and 2 will go into 6. So divide by 2, divide by 2. So I end up with 1 and 2 over 3. That's having that basic fund of knowledge and math facts where you can easily multiply smaller numbers, divide smaller numbers. Makes it way faster than trying to put everything into a calculator. It's much easier to do it mentally. Look at subtraction next.